Hi, this is a presentation on computer networks and put through with shot with screencastify. I'd like to talk briefly about the definition and purpose of computer networks, how the computers are connected together, the topologies, and a little bit about peer-to-peer and client-server networks. The objective of this: satisfy ministry requirements, terminology related to computer networks, talk about some configurations, how computers are hooked together, and the topologies, and then talk a little bit about some businesses that would use certain configurations of networks. Before we go too much further, we need to talk about what a network is. A computer network is something that allows computers to connect and communicate together. The computers must be connected then, and they must also be able to communicate. They can communicate for the purposes of sharing information or sharing resources. Businesses use networks to reduce cost, to share software, and to collaborate. When the businesses buy things like printers for their office, they don't buy one printer for every single desktop. They allow various users to share printers, and that saves money. They might also have more expensive equipment like plotters or scanners or some other things, equipment that gets used infrequently and therefore doesn't need to have multiple pieces of it. They could also use a network to centralize group policy, so permissions on various things and abilities of computers to do various things, or abilities of employees to do various things like change files or that sort of thing, as well as providing a centralized place for employees to store data files, and that makes backing up those files much easier. Businesses have networks so that they can share software and data. You're probably used to installing software on your particular machine, all the applications that you need. Sometimes that same software is available in a network version, in which case the company would install that software on the server, run it off the server, and buy network access licenses for that software, and that would be cheaper than buying multiple copies of the actual application. They could also have centralized templates like standardized forms or company letterhead that employees would use regularly, and that could be kept updated and stored in a central location for all the employees to access. As far as collaboration is concerned, that means that employees would be able to work together with the same applications on the same files. It could even be like we've done with Google Docs or Google Slides, where you can have multiple people actually working on the same particular file. And lastly, again, centralized documents, as I mentioned before, making sure that those documents that are used are up to date and employees have the proper version so that you don't have old versions of things kicking around. In order for a computer to communicate on the network, it has to have a network card. The network card can be a physical object like shown here, or it can also be a device that's built into the motherboard on the computer. In any case, that network card does have its own unique address, and that's how they're findable on networks. And the network card acts like a virtual postal system in that it can send and receive messages. The messages are called packets, and the packets hold the data. So the network card would get information from the CPU that the CPU wants to send someplace. That information comes in parallel. As you know, today's CPUs process parallel. So the network card has to put that data into, in a way, a linear package, so the bits can go on the network medium one at a time. It also needs to add a destination address to the packet or the envelope that holds that information. And when it has all that, then it sends it onto the network medium. Network medium could be wire cable, like coaxial cable on the TV, or twisted pair like Ethernet cable. It could also be fiber optic cable, or it could be wireless radio signals, depending on what the network card is. The network card also spends time listening or waiting for packages to come. If it hears and finds a package that's addressed to it, then it'll open the package, it'll reassemble the data in such a way that the CPU can work with it, and then pass it on to the CPU. Now we get to topologies, and topologies are ways of connecting computers together in networks. The first one we'll take a quick look at is the bus. And by the way, I borrowed this image from and the following images from Wikipedia. The computers are all connected together on one main cable. It's a cheap way of doing it, fairly efficient, good for a business with 6 to maybe 10 computers probably. Main disadvantage, if the cable breaks or a T-connector breaks, the network goes down. And if 2 computers try to transmit at the same time, we have something called a collision or a packet collision. In that case, the messages need to be resent. And if you think about it, then having lots and lots of computers on the same bus, the more chances are that 2 will try to transmit at the same time, the more packet collisions. So that means that the network gets slow with lots of computers on the network. So a better one would be the star. And in that case, all the hosts or all the computers are connected to a central hub, and the hub manages and controls all of that flow of information. And if needed be, it can act as a repeater too, because some of the wiring from the computers in the office space can have to run a long distance to get to the actual hub. The advantages, you can add and subtract nodes quite easily from here without disturbing the network. The disadvantage, if the central node quits, or the hub quits, then the network is obviously going to go down, and you're going to need some specialized software so that the hosts, the computers, can talk to each other well, and it will allow simultaneous communication between pairs of computers. The ring topology, basically computers are connected together in a ring, one to each one. Information passes from one to the next in the same direction, always around the ring. So if it's a short ways around the ring, it'll happen fairly quick. If it goes a long ways, then the information has to get handled a number of times. That's one of the disadvantages. This would work well again for a office situation where you have maybe 6 to 16 computers. The more computers that are on the network, the more times those packets need to get handled, so the slower the transmission will go. The packet collision factor is eliminated because there's a token that gets passed around the ring from computer to computer, and if a computer wants to transmit a message, it has to wait till it gets the token. When it gets a token, it can transmit its messages, and then it'll pass the token on again. So the only device with a token can transmit. Some other disadvantages: if one of the nodes on the network quit, then the network goes down, or if the main cable is also broken, then obviously too the network goes. And sometimes there will be an inner ring set up so that there's some duplication of the actual main cable. The last one we're going to get to is topology. It's a tree. It's a blend between the star and the bus. You can see that the middle hubs of the stars are connected together with a bus configuration, and inside the stars you have the actual computers that will transmit to each other through the node. This would be good in a department business where there's lots of interdepartmental traffic, where lots of computers in the department need to talk to each other, and there wouldn't be quite as much traffic between departments. It could be a little expensive to set up because you might need some more expensive routing equipment. The last thing we get to here is peer-to-peer and client-server networks. Peer-to-peer is something that you probably are most possibly familiar with. You have your own machine with all its own information, all its own applications on it, and there's some space set aside on the hard drive for shared files. And if you wanted to share files, you would put it in that space, in that folder, and others could access information from there. You could also share printers or other devices with special switches. Then we get to client-server, where we have a centralized machine that provides a variety of services to its clients. It could be all of the applications on the server, in which case you would have a thin client and basically just a monitor and a keyboard. Or you could have a thick client where the actual things attached to the server have most of their own applications or all of their own applications and would only require print services, authentication services, and centralized file storage from the server. So that would make it best for the company in that it's easier to back up from one place, back up files from one storage area than from multiple storage areas. Thanks for watching this presentation. Have yourselves a good day.